Hello, good morning. In this tutorial, we shall discuss all the steps of time series analysis. If you have not yet subscribed to my channel to get free access to data files, subscribe the channel and write your email ID in the comment section. As you know that there are three main types of data: cross-sectional data, time series data, and panel data. Today we shall discuss about the time series data. Time series data is a data in which cross-sectional unit remains fixed while years change. For example, if we collect the data one firm from 2001 to 2023, as there will be one firm only, so cross-sectional unit is 1 and years are changing from 2001 to 2023, so years are 23, so we will call it time series data. The equation of time series regression is written with the subscript T. You can see the dependent variable is exchange rate with subscript T, and independent variable it has been written as beta, also have the subscript small t. Now we'll discuss here the major steps of time series analysis. So this is the overview of entire time series analysis. We start from investigation of stationarity, and by application of augmented Dickey-Fuller test and Philip Perron test, we investigate that whether all the variables are stationary at level or not. If they are stationary at level, then we shall run OLS at level, and if the variables are not stationary at level, so if stationarity answer is no, which is also known as unit root investigation, then we check their order of integration. By order of integration, we mean at what difference level they become stationary. Many macroeconomic variables become stationary when they are measured in first difference form. So, including all the independent variable as well as dependent variable, we shall try to see what is their order of integration. It means that if at level they are non-stationary, whether they become stationary at first difference or at second difference, or some variable become stationary at first difference and some variable become stationary at second difference. So if the order of integration of all the variables including dependent variable is same, then we shall move towards co-integration. However, if variables are non-stationary at level, but their order of integration is different, which means that some variables become stationary at first difference while some variables become stationary at second difference, we shall call that their order of integration is different, and then we shall run ARDL model, which is autoregressive distributed lag model. However, if variables are non-stationary at level, but including dependent variable, all variable becomes stationary at the same difference, whether it is first difference or second difference, but it should be same for all variables. Then we shall see whether those variables are co-integrated or not. By co-integration, we mean that is their linear combination stationary or not, or in simple words, you can say that do those variables have long-term relationship with each other or not. Here we shall use the Engel-Granger approach of co-integration, and we can also use the Johansson-Jusselius approach of co-integration. So in short summary, they are known as EG approach and JJ approach. So after running the co-integration, if we conclude that those variables are co-integrated, which means that they have long-run relationship, or technically speaking, the linear relationship of non-stationary series is stationary, we conclude that they have a long-term relationship. And co-integrated means if yes, they are co-integrated, then we can run OLS at level, and we shall move towards error correction model for short-term relationship measurement. However, if we conclude that those variables are not co-integrated, then we shall run the first difference form. So this is how the time series analysis is done stepwise. So if we are running error correction model, it means that at this first step we concluded that variables were non-stationary at level and their order of integration was same, and through application of co-integration techniques we concluded that those variables are co-integrated, which means that they were having the long run relationship, and then to measure the short term relationship we are applying error correction model. Now, starting from the step 1, we shall see here in the next slides that what do we mean by stationary series, and how stationarity test is run in EViews, and how is it interpreted. Stationarity issue, which is the first step to start time series analysis. A variable is said to be stationary if its mean remains constant over time, its variance remains constant over time, and simple correlation coefficient between current value and lagged value of a variable simply depends upon the lag of length, and this simple correlation between current and lag value does not depend upon any other variable except the length of the lag. Now, to run OLS on time series data, all variables, including dependent variable, need to be stationary. And if variables are non-stationary, but we run OLS on non-stationary series, the results will be spurious regression, and its consequence will be that we may get higher values of t-score, which are actually not. So by running OLS on macroeconomic variables, on time series variables, which are not stationary, there is a possibility that we conclude that our independent variables are highly significant because of higher values of t-score, which actually might not be based on any economic theory or economic relationship, that is due to non-stationarity or because of presence of trend in those variables. For example, if we run OLS on nominal variables, we know that major component of nominal variable is inflation. So because of inflation component in many macroeconomic variable, we will get the result of higher t-score, and we will conclude that our variables are significant, but actually they may not be based on any economic sense or economic theory. They are appearing as significant just because of presence of inflation in those variables. Therefore, we need to check whether the variables are stationary or non-stationary. On non-stationary series, we should avoid using OLS at level. Now, how is it investigated? We have two commonly and widely used tests to investigate the stationarity issues in any macroeconomic variable. The first test is augmented Dickey-Fuller test. It takes into account the correlated error term by adding lagged values of dependent variable, which I shall explain in the next slide. And after ADF, the second most commonly used test of data stationarity is Philip Perron test. Now here see how augmented Dickey-Fuller test works. See here, if we run a regression y may be any variable, we are running autoregressive model of lag 1 where dependent variable yt is being regressed on its lagged value. Now, if absolute value of beta 1 is less than 1, then y variable is stationary, and if absolute value of beta 1 is greater than 1 or equal to 1, then variable y will be non-stationary. A special case where beta 1 will be equal to 1, that will be non-stationary, but we call it unit root. Now, if we subtract the lagged value of y from both sides of this equation, we shall get this equation 1 where we are subtracting lagged value of y from both sides of the equation. Then dependent variable will become delta yt, and from these two values, if we take yt minus 1 as common, in bracket we shall get beta 1 minus 1 plus error residuals. Then we uh, can assume that if beta 1 minus 1 is equal to gamma, then this equation 3 can be rewritten like this, that delta yt is equal to gamma into yt minus 1 plus residuals. Now this equation 4 was used by Dickey-Fuller test, and in the Dickey-Fuller test later on, because this residual could be correlated with this independent variable which is lagged value of the y, to control this or to tackle this problem of correlated error term, they included the lagged value of dependent variable in the equation as well. So basically this portion sum of delta yt minus k, where k is equal to lag length plus residual. So this is the value of dependent variable to control the possibility that error term could be correlated with the uh, independent variable. So null hypothesis of this augmented Dickey-Fuller test is that this gamma is equal to 0 and this value is equal to 0, and we know that this value will be equal to 0 when beta will be equal to 1, because this is equal to beta 1 minus 1, and if beta 1 is 1, it means that there is unit root problem or variable is non-stationary. Therefore, in text we can write that null hypothesis of augmented Dickey-Fuller test is that there is unit root, or in simple words, variable is non-stationary. Now we shall go to the e-views and we shall see how to run the augmented Dickey-Fuller test and how to interpret its result. Okay, here we are now in the e-views. In the command window, we shall type open to open the file where we have saved it. So go to your file where you have saved it on your laptops. Here I have an introductory econometrics for finance previous work file, and here UK housing price file, UK HP. If I open it, now I shall open this variable which is housing price HP. I have opened it. Now I want to run the augmented Dickey-Fuller test on this variable. Go to view, unit root test. Here augmented Dickey-Fuller test, run it at level first. You can include the intercept in the equation and maximum lag length equal to 14. Click OK to see the output. Here, know that null hypothesis of this test is that HP as unit root, or in simple words, that this variable, housing price variable, is non-stationary because p value is more than 0.05. Therefore, we are unable to reject the null hypothesis and we conclude that at level this variable is non-stationary. Now we shall run the unit root investigation at first difference and we'll see that whether this variable becomes stationary at the first difference or not. Go to the view, click unit root test. Here now select the first difference. If you click OK, you will see that now p-value is less than 0.05. Thus, we reject the null hypothesis because we know that we reject the null hypothesis when p-value is less than level of significance, which is generally considered 0.05. So, we shall conclude that this housing price variable was non-stationary at level and it becomes stationary at the first difference. Now we shall run the Philip Perron test. Go to view unit root test. Select here Philip Perron test. Check it at level. So again, this is non-stationary at level. If we use PP test, again go to unit view unit root. Click on first difference. So, using both augmented Dickey-Fuller test as well as Philip Perron test, we have concluded that this variable is non-stationary at level and becomes stationary at first difference because p-value is less than 0.05 at first difference.